All right. Again, if you guys know your exponent properties and log properties are going to be pretty basic. So let's run through these and then let's compare them to what we know about exponent properties. So if I have multiplication on the inside of a log, that translates into addition on the outside of a log. All right, and that should make sense to you because what are logs again? Logs are exponents. And when do we add exponents? We add exponents when we're multiplying two things together. That makes sense to me, right? An equivalent exponent property is if I had b to some power times b to some other power, that would be equal to b to those powers being added together, right? You did this last year, yes, for sure. All right, similar idea, except we're dividing here. What do we do with our two powers when we divide two things with the same base? We subtract the exponents. That would be b to one power minus the other power. So division inside of a log translates to subtraction on the outside of the log. Power rule. Now this one I don't have a good analogy for in the exponential version, but it's really kind of a special version of the product rule. I'll show you why in a minute. But it says that when we have an exponent on the inside, that translates to a coefficient on the outside. Right? Do you guys remember kind of taking the exponent and moving it out front, or vice versa? And I'll give you a good reason why this works. What if I had, let me just give you an example. The log base 2 of x to the third. Would you agree that that is the log base 2 of x times x times x? Isn't that what x to the third means? Yep. And based off of this, what am I going to do with all these things when I pull them out into their separate logs? They're multiplying on the inside. That turns into addition on the outside. Plus log base 2 to the x plus log base 2 to the x. But what self-respecting mathematician would actually write out the same thing being added together 3 times? They wouldn't do that. What would they do instead? They would put a coefficient of 3 out in front. So you see how this is really just a kind of a special case of this. I don't know what this rule is called, but the log base b of 1 always has the same value.
0?
Because b to the 0 power is equal to 1, so log base b of 1 is 0. All right, so let's do a couple examples of this. We're actually going to do 3 examples. Well, we'll do 4 actually. This first one. When you look at this log, I see stuff being multiplied on the inside. How many things do you see being multiplied on the inside? I saw 3 also. So I'm going to have 3 logs. They're all going to be the same base, and they're going to be added together. And what are those 3 things that are being multiplied? It's 8 and x and y to the 4th. Now, a lot of times our instructions are going to tell us no radicals or exponents in our final answer, or avoid as much as possible radicals and exponents in your final answer. So we want to do something with this 4 here. What could we do with it? Bring it out, make it a coefficient. So the final answer would be log 8 plus log x. I'm certain you did this last year. Yes, Absolutely. Like maybe a day. Yeah. Yeah. Second example here, I see division. You see division here also? Division. So I could write this as 2. The base is going to stay the same, so they're both going to be natural logs. They're going to be subtracting from each other this time. One of them has a square root of x squared plus 5 in it, and one of them has an x. And if they're telling us to avoid exponents and radicals in our final answer, then we could do some stuff about that radical, couldn't we? How can we rewrite a square root? A negative power? Fractional power, there we go. To the 1/2. Oh, we still got an exponent on there. Can we do something about that? So we could take this exponent, make a coefficient. That's looking pretty good. I'd really like to get rid of this square on this x, but I can't do that unless it's an exponent on the entire inside of the log. Can we split this up though? Addition on the inside of a log translates to what on the outside? Addition on the inside translates to what on the outside? Addition on the inside translates to what on the outside? This could be a trick question. Addition on the inside translates into, it doesn't. I'm not hiding anything from you. These are the properties. There is no property for addition on the inside. So we can't do anything about this. It's stuck like this, which means we can't do anything about that exponent either. So that's it. That's as far as we can take it. That's it. All right, scratch this out down here. Let's work this up here, and then because I've got another one I want us to do after this. I'm scratching this duplicate out here, and we're just going to work it up here. I would love to put these two ln's together, but right now I can't because of that coefficient. If we've got coefficient, you can't put them together. So what can we do to get rid of this coefficient here? You want to bring it up? Turn it into an exponent? Let's do that for our first step. Was that how you meant? Or did you want to bring the negative up there with it? I mean, we could, or we could just leave the negative here. I don't care either. Let's go with it like this. And then now we can go ahead and put them together, right? Negative means what are we going to do on the inside? Subtraction on the outside translates to division on the inside. So what do we got? X to the 5th minus, and I'm going to go ahead and simplify that. Let's square both of them, x squared and y squared. And then we just do a little bit of canceling and we're done. We have 3 x's left on the top and none on the bottom. Just y squared. And that'd be it. If we had brought the negative up, we would have been adding, and it would have been xy to the negative 2, which means we would have multiplied but then put them on the bottom anyways, so we would have come up with the exact same answer. All right, I got one more I want to show you. This one's kind of a weird and tricky, kind of fun one, I think. That's why I wanted to leave some space down here. So here we go. Are you ready? We've got ln x minus ln y plus ln z minus ln c. How would you go about doing this? We want to turn this into a single log. How How are you thinking about it? What would you do first, the minuses or the pluses? Or you do the minuses first? So if I combine these two together, we get ln of x over y. Plus, and then combine these two together, we get ln of z over c. Could do that. And then when we combine them into a single log, what are we going to do with these two fractions? Multiply them together. When you multiply a fraction, you just multiply top times top, bottoms times bottom. We'd get that, right? And that's the right answer. There's another way to do this. So check this out. I'm going to rearrange. That's ln x plus ln z minus ln y minus ln c. So I'm getting all my negative ones at the end. And then I'm going to group my positive ones together. That's ln x plus ln z. And then I'm going to factor a negative out of these two, ln y. What's going to happen to my minus ln c when I factor that negative out? Plus ln c. I would say that's ln of xz minus ln of yc. Agreed? So what's my final answer? This divided by this. Xz over yc. Hey, that's the same thing. So I usually show my students both of these. And then a few years ago, I had a student come up with this gem. So here you guys go. Don't miss this. She said, well, if everything's being added, subtracted, if you have addition and subtraction, you're going to end up with a fraction in your final log. And she said, any of the positive logs are going to end up on the top of your fraction. Any of the negative logs are going to end up on the bottom of your fraction. Right? So she would have just gone, all right, ln x, that's positive. So x goes on the top. Y is going to go on the bottom because it's a negative log. Z is going to go on the top because it's a positive log. C is going to go on the bottom because it's a negative log. Do you guys agree with that? Totally, yeah, because you can always, and the explanation that I got is you can always think of this negative as a -1. Bring it up, that's y to the -1. That's going to be on the bottom of the fraction. So anyways, I thought that was pretty cool. Thought I'd share it. Let's go on. We're almost there. Oh, this is a fun part. I'm going to write down the page number for you here. I want you to write this down. 312. And I would also like you to put a little star here and write yourself a note. Review. Oh my gosh, I can't spell. Review before chapter 3 test. And it's on page 312. I'm going to actually open up the book. I really love that they include this in our text. Do any of you guys ever read this section in the textbook? Like whatever we're going over? Good for you. I don't know if I've told you this before, but when you get into college, that'll be the expectation, right? Showing up to class and taking notes, that's like 1/3 of your job in college. You should be taking notes you should be reading the section and taking your own notes before you go to class, and then going to class and taking notes with the professor. So you've got an idea of what you're going to be learning and what kind of questions you might be asking. And then the other third is just doing your assignment and getting help with those. I love this in our book, though. They provide a lot of opportunities to check for common mistakes. So that's what they're asking you to do here. So we're going to go through here and do true or false for each of these statements. And a lot of these are super common errors, which is why I think this would be a really good thing to review before your test. So first one's false, you think? The first one is kind of claiming that addition on the inside becomes addition on the outside. Is that true or false? That's definitely false. What change could we make to this equation to make it true? If we made this x times 2, then it would work, right? Multiplication turns into addition on the outside. So if this was x times 2, that would work. All right. Number 2, the claim here is that looks like multiplication on the inside turns into, oh, sorry, coefficient on the inside becomes a coefficient on the outside. True or false? That's also false. What could we change about this equation to make it a true equation? I would change something over. Yeah, we could make that 7 instead of a coefficient, make it what? Exponent. You guys, why don't you pay attention here? Come on. All right, so that one was false. Number 3. This is kind of making the claim that multiplication on the inside becomes addition on the outside. Is that true or false? That's true. Number 4 is kind of showing division on the inside becomes subtraction on the outside. Yeah, that's true. Division becomes subtraction, yes. Number 5 is showing division becomes division. This is one of the most common mistakes that I see, but that's totally not true. How could we fix number 5? I'd say we need to change this side of it. Instead of division, what should we have here? We should have subtraction, yeah. How about number 6? 6 is showing that an exponent of 3 can move out front and become a coefficient of 3. True or false? That's true. 6 is true. What's 7 trying to show us? We've got x squared here, and then we've got 2 copies of the same thing out here. I guess it's kind of saying x times x, so multiplication becomes multiplication. No, that's not true. What could we change over here to make that true? You could put a plus in between instead of multiplying. Or, if we got rid of one of them, where would we put the 2? Out in front. We could make that 2 into a coefficient. But as it is right now, it's definitely false. Number 8's kind of weird. I wasn't sure on this one. What I ended up asking was this question. This would be true as long as the absolute value of 4x is the same as 4 times the absolute value of x. If that's true, then I think that this is true. Do you think this is true? Is the absolute value of 4x always going to be equal to 4 times the absolute value of x? Let's test it. So with absolute value, if it's true for negatives and 0 and positives, then it's true. So pick a negative number, negative 10. Put negative 10 in for x. Is it true if we put negative 10 in for x? We would get positive 40 on both sides. That works. If you put 0 in there, you get 0 on both sides, so that works. If you put a positive 10 in there, 40 equals 40. Yeah, so this is true, so that means that 8 is true also. So if you'd like to, you can copy down an answer key here. This is not going to be useful to you in itself, but if you can remind yourself to go back and look at page 312 before your test, it might help you catch some of those common errors before you turn in your test. All right. One more thing. You guys are almost there. All right. This next one is change of base, and there's kind of 2 things going on here. I want to show you why we're doing this, because a lot of times my students are like, well, I don't need to know this because my calculator can do this for me. And your calculator can. Most of your calculators can. But you need to know it for some other reasons too. So for example, let me give you a problem. We're going to come back to this in a minute. If I asked you to turn this into an equation with a single log, could you do it right now? The bases are different. Bases are different. So at this point, we could not put those together. Is that a phone? My goodness, if it is, put it over. Come on. Not convincing me. So the only way we could do this is if we could either change this base to a 4 or this base to a 2. So we're going to come back to this in a minute, but this is why we need a change of base formula, okay? Now, you're not going to see problems like this until the next section, until next Tuesday, but they're going to ask you to practice the change of base formula in your assignment. And I'm going to tell you, you can do all of the problems in your assignment by just simply typing them into your calculator. But if you do that, you're missing the opportunity to practice kind of firming this up in your head, how this whole thing works. So let me show you how it works, okay? You ready? If I want to change a base, say from a B to an A, I can do that because the log base B of x is equal to the log base A of x over the log base A of B for any values of A and B and x. Now, the main reason they used to teach this, not the main reason, one of the big reasons they used to teach this is because most older calculators only had 2 different log buttons on them. And if you look at the face of your calculator, the only 2 log buttons that you have on your calculator have what bases? Natural log, which is a base of E, and common log, which is a base of 10. Your calculator doesn't have a log base 2 button on it. Now, it can do a log base 2. It's under math, and it's one of the last options, but I don't even want you to even know it or learn it, okay, for 2 reasons. One, doing it the way I'm going to show you is actually faster. It is faster. It's less buttons to push. And 2, if you know how to do this, it's going to help you do some other more complicated stuff later, okay? So as long as I have the same base top and bottom, and I do the inside divided by the base. So I could use any base I want to, including the common log. So common log of x over the common log of b would be another way to do this. Or I could use the natural log of x over the natural log of b. It doesn't matter. For that matter, I could do the log base 42 of x over the log base 42 of b. Those are all going to come up with the same value. So it doesn't matter what a is. Basically, I'm telling you that a can be anything you want. It can be 10, it can be e, it can be 42, it can be any other number that you pick that's a legal base, right? Positive number. So if I wanted to know the log base 3 of 16, yes, there is a button in your calculator that will allow you to do it, but the other way I could do it is I could just type ln 16 over ln 3. And if you've got your calculator with you, I'd like you to try that right now. ln 16 over ln 3. Don't forget your parentheses. And we're just going to round this off to, say, 3 decimal places. 2.524 is what I'm getting also. Why did I choose ln instead of log? Because I could, because I felt like it, because I'm lazy and I didn't want to write down 3 whole letters. I could have done log 16 divided by log 3, and I challenge you to try it too. You should get the exact same answer. Now, there is a way that you can actually type it in directly. I will tell you how to do it, but I don't want you using it. It's under the math menu. I go up instead of scrolling down because it's closer to the bottom than it is to the top, and it's log base. This will look different for some of you that have the fancier math print installed. If you have the log base one, you have to put in the 16 and the 3, but they go backwards. So you do the 16 first, comma, 3, and the parentheses, and hit enter. But if I timed myself typing this in and I timed myself typing this in, this is actually faster. I don't have to go into a menu or anything like that. Yeah, you could memorize the shortcut for it, but come on. Like, yeah. So why do I want you to do it this way? Because this isn't going to save you when I give you an equation that has logs with 2 different bases on it. You still need to know how to do this. So I want you to practice. And I will tell you that on the test, and I'm just being transparent here, this is the exact instructions that will appear on the test. If this was a 4-point question, this would be worth 2 points, and this would be worth 2 points. And if all you give me is the correct answer, you're only getting half credit on that question. Because in the instructions, I will specifically instruct you to use change of base formula and show your steps. All right, so if I go ahead and type this second one into your calculator. Let's do logs this time. Log 10 over log 6. I'm not feeling so lazy this time. Log 10 over log 6. Actually, I'm going to see if I can guess the answer to this before I do it. What is the exponent I put on a 6 to make it equal to 10? It's less than 2, I know that. Bigger than 1, less than 2? 1.3-ish? 1.2-ish? No? Uh-oh. 1.1-ish? I don't know. Let's see. Log 10. It's definitely less than 2, right? 6 squared would be 36. That's too big. 6 to the first is 6. So it's too small. It's somewhere between 1 and 2. Log 10 divided by log 6. Yeah, 1.3-ish. Not too far off. Of course, I've done this problem twice already today. 1.285-ish. This last one you ought to be able to do in your head before you type it in your calculator. What exponent would you put onto a half to make it equal to 2? -1. This is going to be equal to -1. But type it in your calculator as ln2 over ln.5 or log 2 over log 0.5. Make sure you're getting -1. Yeah. All right, I want to go back to this problem over here. You can do this over in the margin if you like, or you can just watch. You don't need to know how to do this. We'll see this pop up next Tuesday, but I just want to show you how we would use what we just learned. So this is why I want you practicing using change of base, so that when you do see this next week, you can deal with it. So if I want to combine these two things together into a single log, here's what I got to do. I got to first decide what my base is going to be. Do I want to use 2 or do I want to use 4? And usually we'll go with the smaller of the two. So I'm going to change the 4 into a 2. So I'm going to leave this log base 2 of x alone. And I'm going to rewrite this whole log right here as a fraction, but it's going to be log base 2 of something over log base 2 of something else. What's the top going to be? 2x, the inside of the log, and the bottom will be 4. Okay, we're allowed to do that, right? Any log that I have, as long as I'm using the same base, top and bottom, put the inside on the top, put the base on the bottom, it's equal to the same thing. So far, so good? What's the advantage here? Well, you know what the log base 2 of 4 is. That's easy. That's a number. What is that? 2. So that gets us here. Which is better than where we started with because all our bases are the same. Now we still can't combine them together because of that 2 there. So what will we do next? Tell you what I'd do is I will make that divide by 2 into a 1/2, change it into a coefficient because we know what to do with coefficients. That's the same, right? And then that coefficient can come on up as an exponent. Now I can put them together. And if I wanted to turn that 1/2 into a square root, I could. But now it's all together into a single log. And if I were solving an equation, now I'd have a shot at actually solving it. All right. So that's all I got for you guys today. Assignments on the back there. I'm going to just check